morning students, myself Dr. Bharti Patil, working as an assistant professor physics in Maharaja Jivajirao Shinde College, Srigunda, Ahmednagar. We have already started with our syllabus related to solid state physics PH 332, and we have started the first chapter, that is the crystalline state. We have covered few of the points related to this chapter, and during this discussion we come across that the cubic system is the most symmetric one, and your remaining syllabus is related to cubic system. It means that based on lattice parameters ABC and alpha beta gamma, that is the interfacial angles, the cubic system comes out to be most symmetric one among the all other unit cells. Therefore, your remaining syllabus is related to this cubic systems. In today's lecture, we will start our next point related to characteristics of unit cell. And in our today's lecture, we will try to cover few of the characteristics of unit cell. And all these characteristics are related to cubic structure only. As I have told you that there are few of the characteristics of unit cell that we have to cover, and these are number of atoms per unit cell, it is denoted with letter small cell. Then coordination number, it will be denoted by Cn, capital Cn. Then atomic radius, we are going to denote it with small r. Then packing factor, that is APF, atomic packing factor. Then crystal density by rho. It means that all these characteristics we have to cover related to simple cubic structure, body-centered cubic structure and face-centered cubic structure. During today's lecture, we will try to finish two of the characteristics of unit cell, and these are number of atoms per unit cell and coordination number. As I have told you that we are going to use a small z letter in order to express the number of atoms per unit cell. In few of the textbooks, small n is also used, but and while solving our examples, as we have taken the data of textbook, I have used small n also. Therefore, but in our second chapter, as the small n notation is used to define the order, therefore in order to avoid the confusion, in today's lecture I am going to use number of atoms per unit cell. I am going to denote the number of atoms per unit cell by small cell. Then simple cubic structure. What is simple cubic structure? Simple cubic structure is a structure which will have 8 corner atoms only. There will not be any extra atom which is located at the center of unit cell, and this is called as simple cubic structure. If we consider the contribution of each atom, if we observe the unit cell, it will have 8 corner atoms, 12 edges, and there will not be any extra atom, and it is having 6 faces. But so we cannot say that there are 8 atoms which are present in unit cell, because when we observe a single unit cell we are observing 8 corner atoms, but when we place this unit cell in a crystal lattice, then each corner atom is becoming the part of 8 unit cell. Therefore contribution of each atom to the present unit cell comes out as 1/8, and there are 8 such corner atoms present in a unit cell. Therefore, when we try to find the actual number of atoms present in a unit cell, we have to take both these contributions, that is contribution due to the corner atoms and the number of corner atoms. Therefore, Z value in case of SC comes out as 1/8 into 8 number of corner atoms, that is 1 atom per unit cell. And one should know this Z value, because while solving examples, they will provide you only the structure and they will not directly give you the Z value. You should know, that is, as the structure is simple cubic, its Z value must be 1. Then body-centered cubic structure. Body-centered cubic structure is a structure which will have 8 corner atoms and there is a one extra atom which is located at the center of body. In a previous slide, we have seen that contribution due to the 8 corner atoms comes out as 1 8 into 8 corner atoms, that is 1. And in case of body centered unit cell, there is extra atom which is not shared by any unit cell. Therefore, it is completely available. Therefore, the contribution due to the corner atoms 1 plus this one extra atom which is located at the center of unit cell 1. Like this, it gives the Z value as 2 for body centered cubic structure. Therefore, if in while solving example, if structure is given as body centered cubic structure, then you have to take Z value as 2, as body centered cubic structure has number of atom per unit cell 2. Example of body centered cubic structure are chromium, lithium and potassium. Now we will see our third and last cubic structure, that is face-centered cubic structure. In case of face-centered cubic structure, there are 8 corner atoms and 6 extra atoms which are located at the center of each face. During our previous slides, we have covered that contribution due to the 8 corner atoms is comes out as 1/8 as each corner atom is shared by 8 unit cells and their contribution comes out as 1/8 into 8 such corner atoms are present. Therefore, the parts contributed by the corner atoms, number of atoms contributed by the corner atoms is 1. And now, while considering the face-centered atoms, each face-centered atom is a part of 2 unit cell, half part of present unit cell and half part of its attached unit cell. Therefore, it is shared by 2 unit cells and there are 6 such face-centered atoms. Therefore, contribution to the number of atoms per unit cell of the face-centered atoms comes out as half into 6 number of face-centered atoms. Hence, Z value for face-centered cubic structure is 1 plus 3, that is 4. Z is equal to 4 for FCC. And examples of these are gold, silver, nickel and platinum. While solving the example, they will only give you structure like FCC and you have to take its Z value as 4 by considering contribution due to the corner atoms and contribution due to the face center atoms.